Hey there, year 12s. I'm looking at this question here for 9J. It says question 1C, 1E. So the student understands how to get the question, but how to get rid of the powers at the end when simplifying. So I'm just having a look at the solutions for both of them. And so I'm going to have a look at what you mean by the power at the end. Okay, so let's see. Assuming that you understood how to use chain rule, so we know that it's 3x multiplied to this cubic. So this would be a chain rule problem here. I would have had to do the chain rule. So the derivative of 3x should have been 3. So they would have had, they would have had this as u equals to 3x and u dash is equal to 3. Then they would have had v, which is equal to 2x minus 1 cubed, whilst v dash, and assuming you can do chain rule at this point, you would have had derivative of 2x minus 1 is 2, and then times the derivative, so 3 bracket 2x minus 1 squared. So that should give you 6 bracket 2x minus 1 squared. Okay, so that's your derivative for v. So they're using product rule, and we know the product rule is, so delta y delta x is equal to v u dash plus u v dash. So let's see what they've got, whether it's similar. So we would have had v times u, so 2x minus 1 cubed times 3. Let's see if they've got that somewhere. Yep, this is it. So that's their vu dash, and then they had to work out the derivative of v times u, so 3x times 6 2x minus 1 squared, so that ends up being what? 3x times 6 times 2x minus 1 squared should give you 18x 2x minus 1 squared. So let's see if they've got that somewhere, and they do, so right there. Okay, so that means we're pretty on track. So at this point, that's correct. So if you've got that, fantastic. That means you are almost there. You would have done that all correctly. Now, the only thing is you need to highlight, and this is most often in year 12 exams, you need to find common factors. And immediately I see there's a 2x minus 1 and there's a 2x minus 1. That's a common factor. Not only that, it's squared as well, and the cube would also have a square somewhere in there too. So that means I can take out a square out of this, and there'll be a remainder of a factor of 1. And then what else do they have in common? The 18 and 3, they both have a common factor of 3. So you can see that that's why they have a 3 here. They've taken out 3 as a common factor, and they've taken 2x minus 1 squared as a common factor. That's why when you take this entire thing, if you multiply it to 6x, 3 times the 6x will give you 18x, and then 2x minus 1 squared is right there. So that's your first term. Then you take the same thing again. So imagine you took all of this, multiplied to this. So I'll write it again so you can see what they did. 3, 2x minus 1 squared. If you times that by 2x minus 1, can you see that these are two of the common factors? So you would group them together, and then you would just say it's 3, 2x minus 1 cubed, which is what this is. That's what this currently is. Okay, so they've just factorized it, and within this factor, when they factorize it, you can see that 6x plus 2x gives you 8x, and then plus negative 1. So that's how you would have done it. And if you're a bit confused what I'm saying there, it helps you if you try this other method. If that was confusing, another way to think about it to simplify your problem, 2x minus 1, 2x minus 1, it could help if you think of it as another letter. So if you said let a equal to 2x minus 1, then what this changes to is 18x, so this step here, becomes 18x a squared plus 3a cubed. Now a lot of students can factorize this easier, because the other one has too many numbers and students somehow get confused from it. But from here, see, it's pretty obvious that a squared and there's a cube there. A cubed can be written as a squared times a. So they both have a common factor of a squared, and they both have a common factor of 3. So if you were to write it, you would have wrote 3 multiplied to a squared, and if you factorize it, you would have 6x plus a. True? So if you expand it, 3a squared times 6x will give you 18xa squared, and then 3a squared times a gives you 3a cubed. So that works out. True? So you can factorize it there. And the reason why this is easier because there's only a visualization of one variable. So if it helps, you can write it that way, and then at the end of it, you can resubstitute a. So I said a equals to 2x minus 1. You put it back in. It's 3 bracket 2x minus 1 squared multiplied to 6x plus 2x minus 1. And you can see that's how you would get 2x minus 1 squared times 8x minus 1. That's where it comes from. Okay, so that's for C. Let's have a look at E. It should be something quite similar as well. Let's see if we can see the common factor here. So this is your question. They'll likely have said let u equal to 3x plus 1 to the power 3 on 2 and v equals to 2x plus 4. So when you find the derivative, v dash is just 2, and over here u dash, again using chain rule, assuming you've already done this pretty well, so 3 over 2 times 3 times 3x plus 1 to the power of half. So together that gives you what, 9 on 2 root 3x plus 1, and that's it. Okay, cool. And so then now using product rule, delta y delta x should equal to vu dash plus uv dash. So if I put it together, I should be expecting to get something like v, which is 2x plus 4, multiplied to u dash, which is 9 over 2 square root of 3x plus 1, plus u, which is 3x plus 1 to the power 3 on 2, and that's times in by 2. Okay, so let's see if they've got that somewhere. Have they got the exact same line? Yes, they do. So here we go. So this line here is my line over here. They've got 2 times 3x plus, yep, so same thing. Okay, so we both have the same stance here. And then from here, it's about finding what's in common. So what's in common between them all? They decided to multiply 9 on 2 to the 2x and the 4. So the half of 2x gives you 1x, and then half of 4 gives you 2. So they've just multiplied those brackets there. That's how you get this nice whole number here. Okay, so once they've got that nice whole number, let's see what's another common factor. So again, same thing like the previous example I just did, 3x plus 1, 3x plus 1, and yeah, I think that's pretty much all there is. So that's what they did, 3x plus 1, and they're both to the power of half. See, this 3 over 2, you can think of it as it's another way, just to get your head understanding this, half and you get a cube. That's essentially where the idea is coming from. Okay, so I'm taking out half as a common factor. I'm taking half as a common factor. So 3x plus 1 to the power of half is taken out as a common factor. And to replace it, you see 3x plus 1 to the power of half times 1 gives you this first term. Well, it has to be 2, and it's 3x plus 1 to the power of 1. Because when you multiply with the same bases, you would add the powers. If this is confusing to you, that means use my technique from before. Say let a equal to 3x plus 1, and that might make your life a bit easier. Okay, so you can see it as 2 times a to the power 3 on 2 plus 9 bracket x plus 2. Instead of 3x plus 1, you can write it as a to the power of half. So if that helps you sort of visualize it. If you're struggling with the power of half, if that's what's confusing you, another way of doing it is that we know a to the power of half is root of a, correct? And this just means a times root of a. True? Well, if you're not 100% sure there, I can write it out again. See, 3 over 2 is the same thing as saying 1 plus a half. So that means as long as I have a to the power of 1 times a to the power of half, we know that when you multiply the bases the same, you add the powers. True? It's like a squared times a5, you would add the powers. You do 2 plus 5, which is 7. True? So then 1 plus half should give you 3 and 2. Now, if that is true, then another way of looking at this is it's 2a square root of a plus 9 times x plus 2 with the root of a. And then you can see my point. You can see how there's that root a that's in common. And that's why they took out root a, or a to the power of half, as a common factor, which is what I'm trying to say up here. I'm trying to say they took 3x plus 1 to the power of half as a common factor. And that's, how would you have answered this question? You would have said, oh yeah, well then that means this needs to be 2a times root of a to get you that term, and then root a times 9 times x plus 2. You see what I'm doing there? Have a think, pause if you need. And that's how they got this step here. Because this is my a. This is my a term. Oh, sorry, over here. This is my a to the power of half. Inside the brackets, we had 2 times a, and then 9 times x plus 2. That's what I've got over here. Can you see that? 2 times a, and 9 times x plus 2. That's all they're doing. That's all they're doing. A is equal to 3x plus 1. So, if you understood that main component, that was the main area that sets the difference, you had to take the common factor of 3 to the power of half. If you were able to do that, then this is your 2a. That's my 2a plus 9 times x plus 2 there. And all they did was they just simplified it. So here, if we expand it, 2 times 3x is 6x, 2 times 1 is 2, and then you got 9 times x is 9x, and then 9 times 2 is 18. And then simplifying the inside, 9x plus 6x is 15x, and 2 plus 18 is 20. That's your answer there, but notice the 15 and 20 have a common factor. Take out the 5, and that's my answer there. Okay, so I would say the most challenging part here would be for students to find a common factor right at this step. This is the key step. Okay, and what's tricky about it is identifying common factor. That would be a typical year 12 sort of type question. So you do need to be able to pick up on those common factors. And if it helps, use my technique that I mentioned here. Replace it with another letter, one variable, and usually it's easier to see. Okay, as you get better at it, you don't have to.